Hello, welcome back to JP Academy. In our previous session, I gave a detailed explanation on the concept of load flow analysis, where I also explained the objectives of performing a load flow analysis. That is why you should perform a load flow analysis. However, in this session, I will be teaching on the methods of performing a load flow analysis. So without further delay, let's begin. Basically, there are 5 methods of performing a load flow analysis. So we have 5 methods which we can use in order to perform the load flow analysis. And these methods are: 1, we have the Newton-Raphson method. Secondly, we have the adaptive Newton-Raphson method. Thirdly, we have the fast decoupled method. Then we have the Gauss iterative method. And lastly, we have the Gauss-Seidel method. I'll take that again. We have the Newton-Raphson method. We have the adaptive Newton-Raphson method. We have the fast decoupled method. We also have the Gauss iterative method. And lastly, we have the Gauss-Seidel method. Now, the first 3 methods can be found in ETAP version 19.0, while the Gauss-Seidel method can be found in ETAP version 16.0. The first 3 methods which can be found in ETAP 19.0 are Newton-Raphson method, adaptive Newton-Raphson method, and fast decoupled method. So in this session, I will be briefly explaining each of these 5 methods, and I will be giving their advantages as well as their disadvantages. So we'll begin with the first method, which is Newton-Raphson method. Newton-Raphson's method is a complex method which uses quadratic convergence, to tackle complex situations which involves load flow problems. Now, this method is based on Taylor series, and the number of iterations required to reach convergence are less, which in turn requires a lesser amount of computing time. Now, iterations simply means a repetition of a mathematical procedure. So, a load flow analysis works based on the principle of repeated procedures in order to converge. Now, for a load flow analysis to converge, it simply means that the analysis was successful. It is running. Now, this Newton-Raphson's method is known for its accuracy because of its insensitivity to complicating factors like regulation transformers or slack bus selection. I'll take that again. This method is known for its accuracy because of its insensitivity to complicating factors such as regulation transformers or slack bus selection. Now, some of the advantages of the Newton-Raphson method are: the number of iterations are independent of the size of the system. Now, this simply means that if we have a big power system or a small power system, the size does not matter. The number of iterations specified is what it will work with. Another advantage is that it has high accurate solutions in 2 to